Very small but challenging sector of the commercial is the industrial structures. Industrial structures are basically governed by the input side. Why input side is because these are heavy loaded structures. So output side, basically there is no architectural requirement. So client will not be saying, I want it this way. I want I want it to look very beautiful and all sorts of things. It is governed by only the loads, and the loads are most of the times dynamic. For example, the machinery is moving inside, the gantries, the cranes, and the huge amount of load which keeps on changing. And again, the large spans, because if you look at the assembly structures, there will be gantry on the top and you want the spans to be large. What that means is, now the one good part of the commercial industrial thing is the roof it can be very light. So it is typically usually of the steel with the light sheet metal on the top of it. Again, you want it to be faster in construction because industries typically, it's like time is money. So you just don't want to spend more time in constructing those. Now, one typical challenge that you would see because of these large heights is, let's just say if I have the roof of concrete. Now, concrete gains its strength in 28 days, the full strength. If I have to build up the concrete slabs, I will have to do the shutterings on the bottom. Now, if I have a huge span, imagine the shutters standing for that height. Now, it's very challenging to provide shutters for that height. And that is why typically they go for steel structures, because steel you will have a crane standing somewhere and then assembling all these steels, and then they're getting welded or bolted on the top. Concrete, on the other hand, will require shuttering, which will be standing for at least 10 days, 12 days, basis the concrete strength that you're using on the top. And then only you can remove the shutters. The problem is the huge height where the shuttering will be a difficult challenge. The second interesting part is the residential. Now, in residential, I distinguish this into two parts. One is the horizontal development, like you see Gandhinagar or Chandigarh for that example, where the buildings are planned horizontally. There are no tall buildings, but horizontally there will be different type of structures. Now what happens is there are a lot of variations if you look at one building from the other, and variations in terms of how the buildings are and also in terms of what the building utility is. So in a residential township, you would see different types of buildings like hospitals, like schools and temples and other types of infrastructure also. And you would require it takes a huge amount of coordination beforehand. Most of the times what happens is, since the buildings are very typical, the client might want to go for the precast building. So as an engineering professional, you have to have knowledge of the precast engineering also. Another challenge is, since these are horizontal developments, the plots are very huge. The surveys are quite extensive. And if you look at the geotechnical investigation of these plots, you might see variation in the soil profile and the rock profile underneath. So what happens is every building might be looking same, but might have a substructure below ground a bit different. Since it might just happen that rock encountered at, let's say, 2 meters at one building and then 8 meters at other building, you will have to probably design the buildings for different support conditions also. So with all these challenges, the horizontal development is basically equally challenged to the vertical also, because typically vertical developments get a huge attention, but horizontals, I believe, require a huge amount of effort and coordination and knowledge of various parts of the engineering. So, and another function that I would like to talk about in structural engineering is coming out with the costing of the structure. So you need to also know how much concrete would go in a column, slab, and wall, and stuff, and also the steel, so that the client knows beforehand how much will be the cost of the building per square feet. Usually, the cost in the project is calculated rupees per square feet. Right? You have to have the knowledge of that also. Usually, the horizontal buildings have higher effective per square feet cost. Once you build up a building and you can't take it, the higher the building, the better it is, definitely, because you are using the same column over and over again. Of course, it goes without saying that after a point, it becomes more and more expensive. For example, 250 meter, 300 meter tall buildings will be quite expensive. But up to a certain extent, and largely up to an extent, they are economical, the taller buildings. So higher buildings will be having a higher effective per square feet cost. If you look at the vertical developments, we are talking about the high-rise buildings, and this is currently, so all the tall buildings are going to be are till date are residential. The great examples are World 1 towers, which is going to be the highest residential tower. I see a major growth in this sector in other part of the cities also, because currently we see all the high-rise buildings coming up in Mumbai only. But if you look at the other cities, you are not seeing much of the vertical development. Mumbai, being at the seashore and having a limited space, has come up with the tall buildings. Most of the engineering is going currently. And then there are different challenges for vertical buildings, because the major challenge that I see is our codes are not really addressing the challenges of a tall building. Right? So when you go for the design, you just have to rely on the international codes, sometimes get an experience with the international clients also, or consultants also, which have worked in the tall buildings, start to design your building. The problem is every tall building has to go with the HRC, which is a high-rise committee, and also have to get the approval. Now, HRCs are basically government authorities. They approve of the design, and that is where the structural engineers are also sitting. So in HRC, which is a government body, again, the structural engineer will be sitting, and we as a consultant or maybe a developer has to take our designs to them and then get it. So all these things are again a profession of a structural engineer. Tall buildings are really very cost sensitive, because even if you save some cost on one floor, it gets replicated multiple times. So you can imagine how clients see them. They see them as a major opportunity in the saving. Again, since it's a tall building, you want to find out the challenging environment as we go up, because as we go up, the construction becomes more and more difficult. Like, for example, pumping the concrete on the top of, let's say, 150-meter tall building. It needs to be very fluidic, and at the same time, it needs to also get the strength. The other challenges in tall buildings are usually higher strength concrete, like M80, M90 grade concrete, which are not very common in India. It is very difficult to get those high strength concrete. The huge foundations that we look at the base of these tall buildings, like around 3 to 3.5 meter depth of the foundation. You imagine the height of one residential floor going into the foundation. So amount of concrete and steel there. And also the challenges because of the mass concreting for these foundations. If you look at the perspective, it's the foundation of two human average heights. So two people standing over one another is actually the depth of the foundation. Most of these buildings, if you are not getting the enough soil bearing capacity at the base, would require pile foundations also. So all these challenges are very common for tall buildings, and every part of it requires a structural expertise. Every part of it requires an experienced structural engineer. Again, if you look at the typical residential floor of a tall building, since these are usually premium, clients tend to do certain things which provide challenges to structural engineers again. For example, very minimum thickness of the slab so that you get more clear height. And you also want the slab thickness to be as minimum as possible, because that reduces the load on the buildings also. So all these challenges make the residential buildings, the vertical buildings, quite challenging. If you look at the building in this photograph is one of the tall buildings of New York, but the challenges are very similar to New York and Mumbai. For example, we are at the seashore, and there's huge amount of wind load that gets that these building gets exposed to. And when the building gets exposed to wind load, it tries to sway back and forth. So you have to also maintain the acceleration, so that since the humans are staying in the building should not give you the higher acceleration, because people will start to feel nauseatic. It's a very common thing to happen. One of the other advanced techniques that have come up for high-rise buildings is definitely the wind analysis of these buildings. They make these they make it sure that the buildings are exposed to the correct amount of wind, be it higher on the lower side, and also optimize the structure. Sometimes they get higher, they get lower than the code specified loads, and in that case, the cost of the structure can be reduced significantly because it is wind governing. Okay? So all these factors considering are very new, are very challenging in this field. And also very interesting to learn from. Moving on, now the second sector that we are talking about is the infrastructure. And in infrastructure, basically you would see roads, the railways, the metros. But the first part that all these things would require are the bridges. Yeah? And these bridges have their different challenges. If you look at a bridge, every bridge is different from another. The three bridges that are on your screen are three different types of bridges. One is the Kolkata bridge, which is made up of steel. Second is one from Mumbai, it's going through sea. And the third is Sunshine Bridge from Florida, And if you look at the slope of that, it was basically to let the ships pass under the bridge. So every bridge comes with a different challenges. The most interesting challenge being under the sea. So you have to go for the pile foundations. You have to build up foundations in concrete and steel, which can resist the impact of water also. So these are very challenging structures. Every bridge is different challenge, and the challenges are very different from the commercial and the residential market. Again, certain things are very common, like the post-tension cables, or maybe if you look at it that way, is again a pre-stressed. Certain new things about the bridges are again cable stayed bridge and cable suspended that you wouldn't be seeing in the residential or commercial market typically. And steel is quite commonly used in bridges because of the huge spans that we want. The most common part of the bridge is in the recent times being precast and also the pre-stressed. So if you're a career in the bridges or companies which are mostly working into the bridges, you should concentrate on precast and pre-stress. Typically, a commercial and a residential market requires pretty much similar type of expertise, but for infrastructure, the expertise are quite different compared to the other two, residential and commercial. So this is something, again, it's governed by the output. The input are not really that challenging. The outputs are really challenging. The sizes of the slabs and the columns and the beams. The wind loads and the earthquake loads are not really much of a concern. It's usually the dead load governed bridge that we always see. Okay, so moving on, the other part of the infrastructure is again dams and hydropower plants. The dams have their own challenges because you are retaining water, and a huge amount of population might get affected if the damage is that. One part I did not speak about in this presentation is the life of a structure. If you look at the residential building, it's typically 50 years, but if you look at different commercial or where the population is higher, like the hospitals, the dams, and these power plants, they go from 50 to 100 to sometimes 500 of a life. So the structure you have to design for different lives also. And dams is one such examples of that. You would see dams from the British area still standing because they were designed that way. Again, there's a huge load. The logistic is one difficult part, and being a structural engineer, you have to be very putting up an attention onto that part, because how to build up is also a structural challenge. You would say, I can design a column of let's say 600 by 600, for example. But how it will be built is also in the scope of a structural engineer, because there are logistic challenges, and sometimes you might have to do bottom-up construction, or sometimes you might will have to do top-down construction, where you built up the ground floor slab in column first, and then you're going down. So logistic-wise, also you have to look into that. The infrastructure are the roads and the rails. The photo itself is explaining the challenges of the road and the railways. Basically, these are governed by the long distances, right? Any road or railway typically is to cover the long distances, and the challenges associated with the long distances are also part of the challenges for the design of roads and railways. Most of the challenges are not really with respect to the structure, but if you look at the geographical challenges, they are quite significant, like the inaccessible areas and unexplored territories, and unresidential weathers also. There would be surveys, uneven contours, and cut and fails to estimate and optimization, and the geotechnical challenges also again. The major geotechnical challenges that you would see are the retentions, because if you are going through the hilly areas, you would be cutting certain portion, and the retention of that cut would be a challenge, again in the scope of the structural engineer. It would be piling that will be requiring, and then the soil stability. Each and every part of this word itself is an engineering challenge. So piling is a different design, the soil stability is a different design. Each can be achieved by multiple ways, like the diaphragm walls, the piles, and the rock anchoring into the rocks and all. So all these knowledges are really required. The expertise that are typically required are your geotechnical engineering. So that will help you in understanding the soil stability in every part of it. I'm sorry, I did not cover the dams and hydropower plants expertise. Again, here you would require the hydraulics. That's a basic civil engineering course. Would require some knowledge of hydraulics also in this. The roads and railways typically do not have major expertise requirement in terms of the pre-stress and all. But again, These would require bridges, and bridges would require ultimately precast and post-tension bridges and all. So that goes without saying that roads can impose you pretty much every challenge, not one particular expertise as such. The another important thing that I want to talk about is the metro, because with the development of the smart cities, I think metros is one cool thing that is going to be coming in pretty much every part of the country. And metros can impose a lot of challenges. For example, the biggest of the challenges, the metros go through highly populated areas. And it's a default challenge because that is why we are building up the metros. And with that, if you look at the first picture, you would see there are three layers of bridges. One is for the pedestrians and the ground floor traffic. Second is the flyover, and third is the metro above that. And look at how the bridge is spanned, because you couldn't place a column somewhere in the middle. It is taken up from the top. So again, a huge coordination goes into it. The logistic planning goes into it, and different engineering solutions are expected of the structural engineer into it. Stability and life of the structure are different challenges. The second portion of the photograph that you see on the bottom is actually something that is getting built underground. Now, all these metros are not going to be traveling above the head. Some of these would be going in. So a structural engineer needs to again have understanding of the soil stability and the tunnel and all sort of retention sort of a work also. You have to find out certain solutions which are very faster in the construction, and again certain advanced engineering major steel work is also expected of a structural engineer. No particular sort of expertise that you would require, but then post-tension, cable stayed and composite structure are very common. Steels are also very commonly used, and since it's a moving load, you have to understand the dynamic loading pattern also. So that pretty much covers the metros. Now the next part is the government work. Now government is putting up money into different challenging works. So one of them is definitely the statue and the monuments. If you look at the one on your screen, it's the tallest statue in India, and all the challenge that goes with it, because it was placed in a location which was right in the middle of the river. So the statue is one challenge, but the logistic is again another part. Government also works in airport. Airport pretty much is very similar to the commercial retail and mall thing that we spoke about. Every part of it is different, huge spans. The similar challenges that are with respect to commercial retail sectors. The nuclear power plants is very interesting. As I said, the concrete that is used for nuclear power plants is very different, because it needs to be also acting as a protection against the radioactive emissions of the work that is going on. And also the structure needs to have huge life. So sometimes it's also designed for the 500 life of the structure. Space work, you must have seen the Mangalyaan movie. One of the core member of the team was a structural engineer. So you also require structural engineers in the space works also. Shipyards is some part of the gantries and the commercial sector that we saw earlier. The same challenges are with the shipyards. Again, some dynamic loads. Certain government buildings, for example, the offices of government bureaucrats and everybody, you will also have to go into that. The government works in a very different manner like a normal consultant. So the challenges are in respect to that are very different. Like the payments and all sort of things. So more than engineering, you would need to have some knowledge of the business also when you're working with governments and the companies that are working for government. Much everywhere your engineering is actually hands-on. You will have to take a pen and a paper, mouse and a laptop, and analyze and draw and everything. But a very specialized field that requires structural engineering expertise are certain other consultancy services that I'm going to talk about. One of them is the peer review. Why is peer review important is structure is typically seen as the elephant. So for example, let's just say if a building is getting built, the major cost goes into structure. And when a client optimizes that cost, he saves a lot in the end product. So that is why a peer review comes. A peer review consultant is basically having a second opinion on the structure where you can have the maximum of the savings sort of a thing. Some certain structures are very old, and you want to have the audit of these structures, you will require a structural engineer, because a building which is, let's say, 50-year-old has been exposed to various environments and loads and everything, and every part of it might look good from the outside, might be damaged from the inside. And that is why structural expertise is required to audit of the existing and dilapidated structures. Certain certifications are also required of the structural engineers. Like I spoke, HRC will ask the certification of the structural engineer. And every building that gets built require a certification of a licensed structural engineer. So every structural engineer is licensed to his own city. He has a license to provide the professional services, and he gets a number, and that number goes on the design of every building. So this again is a major work that is expected of the structural engineers. Sometimes if you have certain natural hazards like earthquake or certain other hazards which can damage the structure, you have to also provide the audit of the structures that were standing after the earthquake. So it might just happen that after an earthquake, the building might be okay, and then people can stay in it without any measure of the repairs. There might just happen that the building was damaged to an extent that it can be repaired and people can stay in that. So that sort of working also is expected of the engineer. And sometimes it might just happen as the building is gone out of its serviceability and it has to be demolished. So these three things are checked by the structural engineer. And all these three things will require expertise in the next step also. Like if you want to repair a structure, you require an engineer. If you have to damage and then diminish the structure, you will again require a structural engineer. So all these things are also part of a structural engineer's professionalism. The last part of this consultancy services is actually demolition of the existing structure. Structural engineers are also required at government panels and lectures, like I spoke earlier. And also, one of the interesting part is, as I was telling you, is the demolition of the existing structure. Because why it is important is anybody can do the demolition, but it should be done in a way that it does not damage the adjacent structure of the human life. Later on, when it is damaged, the material should be moved from one to another without. So, if you look at the two structures in front of you, when they are demolished, they should fall inside and not outside or sideways. So, this sort of demolitions are very important. And they are called as controlled demolitions. So where the blasting materials are placed and where the structure. So it's basically you are going to demolish the columns or the walls. And that is where expertise is coming into picture, because we as a structural engineer would understand how the building would fall, how the building would behave if one of the elements falls and the sequential damaging of the structure. So all these, they require a very specific knowledge, and not all structural engineers are capable of doing that. You again might will have to run an analysis to check if the expected demolition can happen. So sort of a knowledge is also expected of a structural engineer. Now, I was talking about the different challenges in terms of the inputs and the outputs, and also the expertise that are required for different types of the buildings. One particular point that I would like to talk about right now is the challenges of the human occupied building. And why it is different is typically does not get taught in the schools. And that is why it is important to learn from a structural engineering perspective what are the challenges that they come because of the human occupied. See, humans have their needs, and the basic need is they'll have cars, so they'll require the parking towers, or they will require parkings where in the negative spaces. By negative spaces, I mean the basements. Now, nobody likes to stay in the basements, but they can park their cars in the basement. So as you go into the basement structures, the challenges are again excavation, and then again the shore pile, because excavation cannot stand on its own. So we'll provide the shore piles. As you go down, the water pressure increases, and the bottom slab will require rock anchors because of the water pressure it might just up. Another challenge of the basement is again the retaining wall, because there is a huge lateral pressure coming up because of the soil retention and also the water pressure. Some of the major damages that you see in the videos during the rainy days is the damage of the retaining walls. So again, a structural engineer is called upon once these sort of things happen. The other challenges are like space constraints. For example, the basements are very spatially constrained spaces. Air circulation and other services are also challenging. These challenges are not basically because of the structure. These are basically because of the environmental conditions, and also the challenges imposed by the other teams, like mechanical, electrical, and plumbing services. So let's just say if you have the basement, there would be sewage treatment plants which will have to go certain amount of depth below the ground, And then that will impose the retaining and the shoring and the excavation and all these challenges of a basement by default. On the residential floors where humans are occupying any building, in the residential or a commercial building, they would require a mechanical, electrical, and plumbing services. What that does to your structure is it damages, it creates leads through the structure. The pipes going through any concrete member will create a zero strength zone in that structure. And all these sleeves, and there would be certain embedments in the structural elements also, like the conduits, like the electrical pipings, and certain cutouts are also required by these people. Another thing that human typically require is the vertical transportation. That means you will require a supporting arrangement for the vertical transportation, like elevators and lifts and everything. And these vertical transportation are very sensitive with respect to the limitations. So human occupied buildings have their own challenges in terms of the inputs, like the loads are very different, and also the outputs, because every person will have a different need, and accordingly it will be needed to be catered upon. The basic challenge in the engineering field is communication, is understanding a problem, understanding the need of an architect or a client, and then working a solution around it to find the optimum and most possible solution. Okay? And that requires huge amount of coordination. So coordination with architects, with clients, with MEP consultants, and with every team on the site. Every small detail of the structure will be, a structural consultant will be called upon. So all these requirements are fulfilled by the professional only and can be fulfilled. So we spoke about what is happening in the field. We spoke about the different fields that the structural engineer is required. We also spoke about the expertise that are required. What are the educational qualifications that are required to gain these expertise? Definitely you're required to have a BE civil engineering, because that's the basic of everything. It can also be diploma plus civil engineering, does not matter. This is my personal recommendation, this is my experience, but MTech or ME is one of the essential part of the industries. Like other civil engineering professions can be without ME, but I think the structural engineering is very particular field. The more you are exposed to the particulars of it, the better it is. That is why I suggest to have ME or MTech in structural engineering. It's typically a 2-year course. If you want to go into certain really specific part of it, you can go for the PhDs also. If you have the PhD, the career options are like certain education institutions as a teacher and the government bodies, and certain very particular things like the bridges and precast and pre-tension and demolition. Sort of a thing that you can do. But basically, I always feel that it's the essential is the MTech or the structural engineering.